fill in the blanks with the number that would go in there. But again, I think if we pay attention right from the beginning and stay focused, that's going to really help you a lot. Okay? So do you have a pen or pencil? Yeah, like these ones. Oh. Yeah, we do algetiles and.
We already went through this with Mr. Sherk.
I know.
No, that's my bad.
No, that was awesome. Okay.
We literally went up to here.
Perfect.
We did the whole thing.
All right. How did you do? Did you get a 2, a 6, a 2, and a 6? Oh, you're supposed to do that. So, even though you went over this, Mr. Shirk didn't tell you how to follow instructions? Man. So, some definitions. You remember the word variable? Okay? In math, in our polynomials unit, we used variables, and variables stand for a number, but sometimes you don't know what that number is. Now, when you just write x plus 3, the x could be anything. When you put it into an equation, then there's usually only one value that works. Sometimes you could put it into an equation where no values work, and sometimes you could put it into an equation that all values work, right? Here are some examples. So we have 3 plus x equals 5. If there was a box there, you could probably do it in your head, no problem. You can probably just see if it was like this, 3 plus something equals 5, you'd be able to tell me without doing any kind of fancy math that the answer is 2. So we would say in this equation that x is equal to 2. And there's going to be some of them, like these ones right here, where I think you could just look at them and say, hey, this is exact same as this, except now my variable is y. I know that y is equal to 6, that r is equal to 2, and that p is equal to 6. And that's the only thing that would work. Okay? So these are the equations for the same thing that we solved with the boxes. Okay? Here's an important word. Solve. Okay? These are linear equations, and we're going to be asked to solve for those linear equations. In other words, we want to find out what the variable is equal. That's what it means when we're solving. So often the questions that you're going to get are going to say solve. So at the end of this booklet that you have, the last 5 pages are worksheets. Worksheet 1, worksheet 2, worksheet 3, and worksheet 4 and 5. Okay? Yeah, it's like working backwards. Okay? Yeah, we've already done that. We've already done this, but now we're formally doing this now in this unit. But so many of the grade 9 units interlap, right? And yeah. And we've done these. Okay? And some of these ones, worksheet number 1, I think you could fly through some of these. And most of these with worksheet number 1, you probably could just look at it and see the answers. Like x plus 9, something plus 9 equals 18. You might be able to just look at it and say, I know the answer is 9. Okay? We're going to learn techniques for these, and the techniques for these will be what you do to one side of the equation, you do to the other side. We talked about undoing BEDMAS and looking for like terms. For example, the 9 and the 18 are like terms, but they're on opposite sides of the equation. So what we're going to learn as a technique is what I do to one side, I do to the other side. So if I subtract 9 on this side, then I have to subtract 9 on this side. And 18 minus 9 is 9, and the 9 minus 9 is 0, so then I'm just left with x on that side. Okay? And these techniques, even though right now, I bet you, almost all of you, could just do this whole page without showing any work, which is great, but you're going to find as the equations get more difficult, you're going to like the technique of combining your like terms and showing your work. For example, sometimes it's not easy to do the math in your head. Like if you go to O, O has decimal places. Something minus 7.8 is 5.2, and all of a sudden, because they're decimals, your brain doesn't like to work with that much thinking. So this would be a good one where you could show I need to add 7.8 and add 7.8. That would make this side just x, and then I could go to my calculator or do this in my head and find out that x is equal to 13. Sometimes when you're dealing with negative numbers, it's easier if you show the work. Something minus, if you look at I, something minus 10 is minus 18. Again, just because you're dealing with the negative numbers, it's not as easy as this one, right? It's not as easy as some of these first ones. Something plus 3 is 8. That one's like, right away you can see that it's 5. But in L, or I, sorry, with the negative numbers, it's not as easy. So this might be one you say, oh, I'd like to add 10 on this side and add 10 on this side. That way I get x all by itself. I can combine my like terms, and then I find out x is equal to negative 8. That might have been easier than trying to do the mental math in your head. So you're going to find that the technique of what you do to one side, you do to the other, works really, really nice. Okay, I'm going to leave the rest of worksheet number 1. You can do it on your own time. Okay? So, we have some equations that we call one-step equations, because what you do on one side, you do to the other side, and it's only one step to solve it. Okay? Equations are sometimes seen as a balancing beam, or here, I'm going to do it as a teeter-totter. Okay? We're going to do it with algetiles as starting. Okay? According to this, on this side we have an x, and we have plus 4. And on this side, we have 6. And apparently that makes it completely balanced. Actually, one of those balance beams with the what are those weight scales that are hanging baskets are technically, mathematically better than a teeter-totter. Have you ever been on a teeter-totter? Okay? Technically on a teeter-totter, this is different than this. Why? Yeah, the weight on the end. So if, you know, now that I look at this, I would say I should probably use one of those chains, balance beams that are holding things, because then it doesn't matter where it is. You know what I'm talking about? Like, I should have had a fancy little... I should have had one of these things with chains hanging like this. Because then it wouldn't matter if you put the one over here or here, it's still balancing exactly the same. Okay? What's this long green one? That's, in algetiles, that's your x. That's what you don't know. Okay? Now, if these two sides are equal, okay, does it make sense that if I take one off of this side, I would have to take one off of this side? And it doesn't take very long. I'll take another one off of this side, 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 until I just get the x on this side. And how many are left on this side? 2. Now, you probably could have told me just by looking at the equation that x is equal to 2. What you're going to draw originally is this. The x plus 4 is on one side, and 6 is on the other side. Okay? Okay? This is the idea that it's balanced. Okay, let's draw the next one. X minus 6 and 4 on the other side. Now, just looking at the equation, can you tell me what x is? 10. So again, do you think you'll be drawing teeter-totters with algetiles to solve all these? No. Okay? But it's the idea. How would I get rid of a negative 1? I'd have to add 1 to this side. So if I want to get rid of this minus 1, I would have to add a 1 to that side. And if I want to get rid of all of them, okay, and this is where the algetiles and drawing the teeter-totter will get frustrating, we're going to start saying, well, I would have to add 6 to this side to get rid of all of those minus 6s. But if I add 6 to this side, I'm going to need to add 6 to this side as well to keep it equal. And then you'll get that x is equal to 10. So question for you. Okay? I'm going to get you to do one more of these with algetiles on your own. So I want you to set this one up with algetiles on your own. And then after that, I think we can go away from the teeter-totter. If you're okay with that? You did all of them? Perfect. All right, how did you do? Did you have 3 plus x on this side? And 7 on this side? And did you figure out that x was 4? Perfect. The reason why the teeter-totter is kind of important, because we're going to get some questions where they give it to you as the teeter-totter. You have to change it back to the equation and then solve from there. Again, the level that I think you guys are at already, you're able to do these ones no problem. So let's look at the next 3 and just solve them without the teeter-totter. Okay? X plus 5, something plus 5 equals 7. Probably can do this one in your head. Now, if you were doing the same thing to both sides, I would have to combine these like terms. I would subtract 5 to get the x by itself, and also subtract 5 there. 7 minus 5 is 2. Again, at these early ones, you might feel like, I don't need to show work, which is fine, but they get harder. So the work showing is going to be important. So for here, something minus 7 is 5. Again, you might be able to do that in your head. If you wanted to show your work, especially when the numbers get bigger, I would like to combine my like terms. Minus 7 and 5 are like terms, but they're not on the same side of the equation. In order to put them on the same side of the equation, what I do to one side, I do to the other. So we're always trying to undo. So the opposite of minusing 7 would be adding 7. And then 5 plus 7 is just 12. Okay? Here, the 3 and the 9, those are like terms, but they're on opposite sides of the equation. If you want to get the x by itself, because you're solving for x, this 3 shouldn't be on this side. The opposite of adding 3 is subtracting 3. And if I subtract 3 on both sides, now I've got 9 minus 3 on this side, that's 6. 3 minus 3 is 0, so I just get x, and then x is equal to 6. The teeter-totter is given to you in the next question. Can you write the equation and then solve it? So here's your equal sign. On this side, what do you have? X plus 2. On this side, what do we have? 3. So if I was doing the same thing to each side, if I want to combine these like terms, I'd have to subtract 2 to get x all by itself, but then I'd have to subtract 2 on this side as well. 3 minus 2. X is equal to 1. Okay? I would also say get into a habit when you're solving to indicate what your final answer is. Some people, I like to put a circle around it. Okay? Some people like to put a box around it. Some people have a symbol that they like to put at the end, at the bottom of it. I've seen many different things. Okay? I love math. Yeah, you could do that. X equals 1. That's disgusting. Okay. Yeah, there's going to be somebody who's going to do this with a red pen every single time now. Right? That's, yeah, this is $5.95. Right? I do it with Sharpie. Tell your parents it comes off in a couple weeks. It still costs $5.95. Yeah. So this side I have x minus 4. On this side I have 4. Well, I like this one because sometimes students on this one, they say, oh, minus 4 and 4, that makes 0. And they're very tempted to write 0 as a final answer here. But we're looking for something minus 4 is 4. So if I wanted to combine these like terms, if I'm showing my work, the opposite of minusing 4 is plus 4. I'd have to plus 4 on both sides. And I get x equals 8. I like to circle my final answers. Some of you might do the bloody heart. I don't know. And the rectangular square thing. So these are called one-step equations. And one-step equations can be solved in one step. Look at that. Whoa. And if you're solving a one-step equation, What you're wanting to do is you're wanting to get the variable by itself by combining your like terms, and you always have to, like we talked about before, undo things. So we had bed masses of our order of operations, and then we talked about SAMDIB, working backwards. Blah, blah, blah. Okay? So here, if I want to get the y by itself, and again, often one-step equations you can do in your head. Something plus 3 is 11. Pretty easy to see what the answer would be. You probably could do that y is equal to 8 in your head. Okay? Which is great. I don't ever want you to become like a robot and not think. And sometimes these equations can get you to be somewhat robot-like. The opposite operation says, okay, 3 and 11, they're like terms. And this is going to be a strategy we're going to use for a lot of equations. Whenever you have like terms, you want to put them together. But you can only put like terms together if they're on the same side of the equation. Right now, the 3 and 11 are on different sides of your equation. So what we do is we say, well, the opposite of plusing 3 is subtracting 3. And if I subtract 3 on this side, in order to keep the equation equal, in order to keep the teeter-totter the same, all right, you have to take 3 off on the other side. All right? If you've ever been on a teeter-totter with a lot of people, or even with someone who's a lot heavier than you and you're up at the top, and they decide to get off right away, boom, right? You come down in a hurry. Oh, that would be a very fun amusement park thing to do. Okay, imagine, this is me being creative in my, imagine this teeter-totter, super long so that this is you, just a little tiny person way on the end, okay? And they're at some sort of amusement park, and they have it set up, and a person the same size gets on the other side, and you're having fun on this super big teeter-totter. But then they go and they have hired a sumo wrestler and comes, sits down on this side, and you are way, way, way up in the air. Okay? Yeah, it's a super high teeter-totter. Okay? They make it super high. So here, that's sumo wrestler's superpower S on his shirt. Okay, so would this not be, now you're sitting way up here, and as a practical joke, you don't know this, but in the ground here, they have a little hook bolted to the ground, which they hook the bottom of the teeter-totter into. And then the sumo wrestler goes, I'm going to jump off. And you're like, and they jump off.
That's me right there.
Oh, and they should, okay, it's hooked into the ground with a 1-foot chain. So when they jump off, you actually start to fall, but only for a foot, and then it stops, just to scare the living daylights out of you.
Do the line.
Would that be scary? Then, yeah, and then they go, and then they unhook it, and then you fall.
Wait, do the line when they fall down. Do the line.
When they fall,
And then do you want to do a dot? Like in that dot, like when it's hurting the spot.
okay, we're getting morbid here. We should erase that. You didn't see that. That didn't happen. If you weren't paying attention, you missed it altogether. Too bad, so sad. Okay. Yeah, it's on the video. You can see it later. Yeah, it's you're gonna have to, it's like Netflix. I might have to have a little thing up the top that says PG-13, excessive violence and gore on this video. Okay, so the next one. Again, the -5 and the 5 are like terms. I know we're going really slow right now, but this is really important because this sets everything up. So if I want to combine those, I've got to use an opposite operation. And what you do on one side, you do the other side. That would leave me with just x on this side. And, oh yeah, I forgot to circle this last one. X is equal to 10. There's your one step. And another thing that I'm going to get you to do for your mental math, after you get your answer, check it. Plug 10 in for x. What's 10 minus 5? 5. Did that equation work? Yes. So you can, and this is, I loved solving equations when I was a student because you could check if your answer was right, which is really nice. Ever write a test and you hand it in and you don't know, how did I do? I'm like, I don't know. These ones, you will know. Because if you check it and it doesn't work, then you know you did it wrong. Okay? Here, minus 10 and 3 are like terms, but they're on the opposite sides. So undo the minus 10, I'd have to add 10. And y is equal to 13. And you can write the x equals on the left side or the x equals on the right side. That doesn't matter. So you could have written your final answer like this. Some people like to always have the variable on their left. So you could write your final answer like that. Y equals 13. I do too. Right? Because it's not very often someone says, hey, can you solve for y? And you would answer them, y is equal to 13. You would think someone was saying it a little bit wrong if they would say 13 equals y. Still the right. And the last one, I'm going to subtract 4 on both sides. X is equal to negative 12. Okay. 4 for you to try on your own. Okay, let's check how you did. Did you get 6? Did you get minus 2? Did you get 0? And did you get 12? Okay. What happens when they're decimals? Exactly the same thing, except you might have to use a calculator. So once it gets to decimals, you might want to show the minus 1.5 on both sides. You might plug it into your calculator and have 3.5 minus 1.5. Some of you could do that in your head. That's fine. X is equal to 2. Here I'm going to add 2.4 and add 2.4. Again, some of you might be able to do that in your head. Others would like to use a calculator. That's fine. Subtract 3.7 and subtract 3.7. So we started off adding and subtracting. Next, we move on to multiplying and dividing. So I'm going to stop this video